Tension. Sometimes we attach a rope, a cable, or a string to an object to apply a pulling force to the object. We call the pulling force exerted on the object by the rope, cable, or string the tension, given with capital T. To pull this book to the right, we need to apply a force to the far right end of the rope. If we think of the rope as being made up of a bunch of particles, then we can say that each rope particle now applies this force to its neighbor particle until the force is being applied to the book and moves the book. When we're working introductory physics problems, we usually assume that ropes, cables, and strings are massless. If the rope particles do not have any mass, it doesn't take any force to accelerate them, so the magnitude of the tension applied to the far right end of the rope gets fully transferred to the other end of the rope without being diminished. This applies even if our rope is bent around a massless, frictionless pulley. Let's say there's a box attached to one end of this rope, and I am trying to lift it using a pulley. Let's say that up is the positive direction. Now, let's say I apply a downward force, T, to the left end of the rope. Since this force is directed downward and up is our positive direction, we have a negative value for this force. Our rope is massless, so the full magnitude of the tension force travels through the rope until it reaches the box, at which point it is applied upward to the box. In this case, the tension force has a positive value since it's pointed upward. The magnitude of the tension force does not change, however. If the magnitude of my pulling force downward on the rope is 9 newtons, then the upward magnitude of the tension applied to the box is also 9 newtons. When you work these problems, be sure to keep in mind which directions your forces are pointing so you can get your signs right, and remember that through a massless rope, the magnitude of the tension force transfers completely.